All right, so welcome to our water lab. Remember, I told you that water is crazy, it's wild about the different things that it can do, and that's all tied up in its polar nature and some of the special things that happen because of that. So right now we're going to look at some of the things that water does. This is the experiment that you've got in the 3.2 of your Explore. Now, you will have the most fun if you do this at home with your parents' permission. With your parents' permission. Do not, after you have flooded the kitchen, come back and say it's Dr. Buchholz's fault. He's the one who told me to do this, okay? So check with him first. But this is more fun when you do it yourself. All right, first of all, I have ye old plain eyedropper here and a penny. Most of us should be able to find a penny. All right, so you take the penny and you put a drop of water on it. Can you see the penny closely? All right, so that's one drop of water. Let's see what happens when I add a second drop of water. Oh, I added two by mistake. Now look at what's happening. That's like a semicircle. That's like a hemisphere of water. That's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm getting really close to the edge before this is going to spill over. But look at that. Look at how high that water is up above the level of the penny. It's absolutely amazing. Now, you will be able to know what that is, what that quality is. That's going to be a part of what you're going to look at on what you fill out. You're going to tell me why it does that. Okay, the next thing we want to test, that's what happens when you put it at a penny. Now remember, a penny is a metal surface. It is completely resistant to water in any way. So our next surface is we have some wax paper. Ordinary everyday wax paper. It's paper that's basically got a layer of wax on it. It's used in cooking. That looks familiar. Oh, so does that. Here we are, we're getting a very similar reaction. That it's like the water doesn't want to be close to the paper, that it's pushing up, that it's holding together in a way instead of getting absorbed in. So we have our penny, which forms our great big mound of water. The water doesn't go into it. We have our wax paper, where it's also forming a little dome. Now I have a napkin. So what happens when I put a little bit of water, a single drop of water on the napkin? Okay, you see what happened. First of all, it hit here, and it made one part of it a little darker, but now it looks like it's spreading out to the side, spreading out over here, spreading out over there. Let's see what happens if I add another drop of water in the center of this. You see the darker part right in the middle, where the most water is, but you see around the edges it's getting darker too as the water moves out through the material. That's wild. Gonna need to check out why that happens. Next thing I have is some aluminum foil. Aluminum foil down here, right? I've managed to put one drop of water on it, and you'll notice it's not completely circular. Over here, it's circular. Over here, it's got kind of a funny shape. And if you look at the aluminum foil, it's got all these wrinkles in it. I wonder if I add another. See, it's still not completely circular, but you see this wrinkle here and this wrinkle over here. It seems to be that that's kind of affecting the shape of it a little bit, that those small rises and dips make a difference. I'm going to add a few more. As we add more water and it gets deeper, those ripples seem to have less of an effect, those wrinkles in it, which is kind of cool. So go ahead and explain to me why that happens. So we have our aluminum foil, we have our paper towel, or napkin, we have our wax paper, we have our penny, and now we're going to see what happens when we add some water to salt. So everybody sees the salt, it's this white, everybody knows what it is this white substance here, so I add a little water to it, changes color. Add some more water, changes color again. It's becoming clear. Not only that, as it goes out to it, you notice how on the edges, the salt flakes, they kind of click a little and they move around. But in here, they stay together. Now, let me add a bunch more water and we'll see what happens. That was not much of a bunch now, was it? Let me add some more. Those salt crystals are getting lighter and lighter. The white color is going away and they're becoming more transparent, because what's going on is that the salt is actually being dissolved in the water. And every time I add more water and let it mix a little bit, it looks like there's less and less salt. The last one here is some oil. So same old cooking oil, whatever you'd make, what you'd make French fries in, etc. We have some cooking oil, all right? What happens if we add water to oil? We saw if it added water to salt, that the salt started disappearing into it. You add water to oil, it's like it's that one little clear spot in the middle of the oil. What if I add more? I made another one. That it seems to form, the oil goes around the water and forms it into like a little tiny bubble of water inside the oil. Kind of like there's a bubble of air inside water. This looks like a little bubble of water inside oil. So that the oil and the water, instead of mixing together, they stay separate. And it keeps on doing that. What you're doing in this lab, first and foremost, is you are looking at all these different things that the property of water causes. What happens when you do this with water? And then you write down what happens. And then what we're going to do is we're going to tie that what happens to the properties of water. Things like cohesion, adhesion, surface tension, being in a solution, being in a suspension. Those are words that we haven't covered yet in class, but they are the reasons that some of these things are happening. So what we're going to do is I want you guys to do as much of this as you can also at home, just to mess with it, and you can add more and add less and fiddle with it more and play with it a little bit. But this shows us a good gamut of the spectrum of different things that water does to show its unique and special characteristics. Thank you guys for joining me here in the lab, and thank you, Ms. Bangley, for appropriately socially distancing filming.